know who's here and who's not. We'll go from there. Okay. Alrighty. So I don't think we're going to take the full time. It's 10:04 now. So we're going to go through 1.1 and 1.2 today. And I think 3 and 4 will be Friday, or not Friday. Wow. Wednesday, the next time we're here. We're not here on Fridays. We'll go from there. Okay. So if you want to scribble notes, you can. If not, you can just watch me do the thing and then I will post the notes after the fact. If I forget, let me know. I'll wait till I'm in my office or at home, depending on the day, to post, and we'll go from there. Okay, so 1.1 and 1.2. So chapter 1 to me is kind of boring because there's no math in it. I like math a lot. But it is the basis we need to understand the rest of the term. So our vocab in this will help us the rest. All right, that was a nice. Okay, so this is 1.1. I forgot the title of it. Okay, we have the population. That is the group. Ooh, that was being studied. We'll give an example after I do my next bit because they go together. Sample. Oh, my handwriting will improve a little bit. A subset. Of population. So this whole semester, we're going to talk populations and samples. So the population is the big group we're studying. The sample is a subset or a smaller group of that larger group. So it's fewer people, fewer things. It could be things or people. Most of the time for us, it's going to be people because we're looking at what people think, what people do. So it's a smaller group of that. So an example of a population. The US. Move it down here. If we're studying the thoughts of the entire United States population, that's going to be everybody. So everyone who, however we define it, say are born here, natural citizens, live here for any length of time, however we want to define it is fine. That is the entire population. So it's really hard to study populations. If you think about a census, we take that every 10 years, and it takes more than 10 years to go through all of the data we get. They're still doing stuff on the 2010 census. They're still looking at that data now. Just because it's so much, it's huge. So it's impractical to take data on the entire population most of the time. So what we do is we get a sample of that, so a smaller group. So maybe our sample would be 1,000 random citizens. And this is going to be our sample. Probably want more than 1,000, but that sounded good at the time. So it's much easier to collect data on 1,000 people as opposed to a couple million. I don't know how many people we have in the US. Millions of people. It's easier. It's quicker. You can get ahead of that. So another example would be everyone who's a student at DMACC. I don't know what our student population is, but it's fairly large. It would take a long time to go through and get statistics on the entire population if we're doing a study. Descriptive statistics are easy. So an example of a sample of that would be people in this classroom. So you are a smaller group of the larger DMACC population. That may not be a good sample for various reasons we'll explore, but it is a sample. All right, does sample versus population make sense? Questions on that? If I talk too fast, please tell me, slow me down. I forget sometimes, and I drink a lot of coffee, and that makes me excited, or at least, not asleep. So I forget and talk fast. Sorry. All right. Also, if I scroll too fast past something, say something and I'll back it up. That's not a problem either. All right. Descriptive. Versus inferential. Oof. So in our class, we'll look at descriptive statistics and we'll look at inferential statistics. Also, spelling is not my forte, I'm sorry. I'm good at math spelling, but not other spelling. So your descriptive statistics are going to be things like, hang on. I don't know. We're just describing the population. So how many of various genders do we have in our population? How old is our population? These things are important depending on what we're looking at. Household income, your height, your shoe size, your weight, things like that can be descriptive as well. Number of kids, the type of house you have, your car, any of these sorts of things are just descriptive. We can't really make inferences. We can't make guesses on our population based on that, but it tells us things. So, for example, men and women think differently about certain topics. So, knowing what your population looks like is important. No, I don't want to go there. Okay, we'll leave that alone. If a person has kids versus doesn't have kids. So if you have kids, your opinions on cost of childcare may be a lot different than someone who either doesn't have kids right now or never plans to have kids. Your opinions on that may be different. So knowing what our population looks like is important. So if we're talking about, say, cost of childcare, and we only interview people who are in their late teens or maybe early 20s and do not have kids, do you think that's a really good indicator of people's opinions on cost of childcare? I don't, because you don't have any skin in the game. You maybe you care, but maybe you don't. It's not important to you. But if you interview people who have kids, their opinions will be different because that is important to them, especially if they're daycare aged kids. Because mine's 13 now, but daycare was expensive. So that's we have different priorities depending on where we are in our lives. It's not a values statement. It's just people think differently as you change, your opinions change on things. So all of that can have an impact on what our data gives us. So that's our descriptive. Our inferential is where we make guesses. Infer things. Opinions about. So if our descriptive data is the number of kids someone has or doesn't have, our inferential data would be the views on childcare. So what do people think about? So we can say we think 70% of people, I'm making that number up, feel this way about this issue. That's our guess. So based on our sample, that might be the data we have. We don't know for sure what the population thinks, but we can make an educated guess towards that if our descriptive statistics are good. They should be approximately what your population is. So if you have a population which is 70% female, 30% male, and that's your population, it's a 70-30, but your sample has all male, do you think that would be indicative of the population? Probably not. So you want your population to look like your sample and vice versa. Okay, I'm not gonna worry about that. Doing it on time. Qualitative versus quantitative data. Your qualitative are your descriptive words. It's the qualities of your data. Honestly, it's words. You're describing something in words. So it's hard to calculate information on qualitative data unless we turn it into something that we can measure with a number or categories or something along those lines. Your quantitative data, numbers. Excuse me. So for example, think of stress levels. The qualitative approach to this would be asking someone how stressed do they feel on do you feel very stressed? Do you feel not very stressed? So I'm asking an opinion. I'm asking you to describe, to tell me in words how stressed you feel or don't feel. And maybe you give a ranking 1 through 5, but it's still a descriptive thing rather than a hard data. Your quantitative, maybe blood pressure measure. I don't know what others, stress levels. So your blood pressure, maybe your blood pressure is higher when you're more stressed, or your sleep. So hard data on sleep quality, maybe you take a sleep study test and you have all the electrodes glued everywhere, what have you. But stuff that isn't someone's opinion, it's measurable data. So that's the difference between qualitative and quantitative. We need both, but I'm biased to think quantitative data is better because we can measure it. I like to be able to measure things and see. I've done statistics in the real world in the past, and I've used both types. Generally, with our qualitative data, we try to categorize it and turn it into quantitative data so we can talk about it easier, so we can measure it easier. One thing, so I worked at a science museum in St. Louis for a few years. And one of the studies we did is we had this little kid area. So for kids like 1 to 4, little ones. And we would watch the kids there, like in a non-creepy way, ish, and see what they would do. So this child spent this amount of time playing with this thing, and here are the things they did. So we'd measure some quantitative, like time spent on each interactive, and then we would say what they did with the interactive. So we kind of combined both. A lot of your qualitative data is going to be observational. You sit and watch something happen and take notes on what happens. Sometimes you have a stopwatch, sometimes you don't. Depends on the type of thing you're looking at. Yeah. Then we have discrete versus continuous. I'm again biased to discrete because I like discrete math, but that's neither here nor there. Your discrete are going to be your categories. Sometimes they're like categories or something that cannot be split into halves. Oof. So your discrete are your whole number objects, and I'll talk about that versus continuous. Measures. Or something you can measure at any time interval constant. Okay, you get to talk to me this time. Take a sec and decide, are these discrete or continuous things? Height. Let's add one more. Okay, so you're at a festival, words are hard, selling shirts at a table. The number of shirts you sell, is that discrete data or continuous data? Discrete. Why? Say that again? Yeah. It's not a measurement. You can't sell half a shirt. If you cut the shirt in half, you're selling part of the shirt. That's still a full shirt. If you can wear it, it's a shirt. Once you've sliced that shirt in enough pieces, it's not a shirt anymore. So yeah, you have discrete. What about temperature? Yeah. Yep, if I measure temperature now, so you think about outside temperature gets a little weird, but think about when you take your own temperature. Your thermometer doesn't just have 98, 99. No, it has 98.4 or 98.7. So you can have a partial measure, like you can be in between degrees and it makes sense. What about money? Yeah, I could see an argument for both of these. We treat it as discrete data, even though we have part of a dollar, so we have pennies. It's still, you can only split it so far before it doesn't make sense. So I could see an argument on that one, depending on what you're looking at. Time? Yeah. Yep. We don't go straight from 10 o'clock to 11 o'clock. We go through all of the time in between. Number of kids? If you have half of a kid, you no longer have a kid. So yeah, we can't take part of one. What about height? Let's say continuous. Oh, look, I did every other and I didn't even mean to. Yeah, you don't go straight from 5'6" to 5'7". You go through all of the things in between. That's how I think about them. All right, 1.2, I will put down the names of these sections going forward. I didn't think to do that today. So that's 1.1, pretty straightforward. 1.2 is also fairly straightforward. We don't get into the good numbers until chapter 2 and 3. So here we have observational versus experimental. Studies. The difference of these is in their names. Your observational study, you watch. So for your observational study, you're just going to watch what's happening, record the data, and that's it. You do not interact with whatever you're observing. You do not change it. There's a little caveat to that. Sometimes you have to interact to avoid being suspicious or to avoid getting yourself or others hurt for the most part. Again, I worked at the Science Museum, and one of the things I did was stalk people through an exhibit. So adults, kids, whatever. I would discreetly follow them and see what they're doing, measure time. And I wasn't supposed to interact with the people. But if the people I'm observing come over and ask me a question, because it's clear I worked at the museum, if I didn't answer their question, that would be very suspicious. So if they came to me and asked me something, I would give them the answer as appropriate. If their kid was climbing on something and about to fall, I would go, help in that circumstance. But I wasn't to do anything more. I wasn't to change what they were doing. I was also supposed to not get caught, but sometimes you do. Like you can only stalk through an exhibit so long before they catch on and yeah, look a little creepy. It was a fun job. I kind of missed that. For an experimental study, we're comparing two or more groups, and one of them has a change involved in somehow. What is a good experiment? Okay, coffee. Group one. So say we're measuring the effects of coffee on energy levels or what have you. Group 1 is going to get real coffee, the good stuff. Group 2, who we're comparing them to, that's our control group, gets decaf, which is yucky, and I don't like it. So we're going to compare the energy levels between these two groups. We would expect the group 1 to have more energy, but maybe that changes throughout the day. So we're comparing these two. If we don't have a control, we'll talk more about that later. If we just give group 1 coffee and don't compare them to group 2, we don't know if there's an actual change or difference. So we're intervening in these groups, we make a change, we do something so we can compare and see what happens. Okay, I will pull that up in a sec. You're looking at your confounding variables are going to be variables that you probably didn't realize were there or you didn't mean to add into your study. So you don't control them, but they have an impact on the study. My favorite example of a confounding variable is we have a relationship between ice cream sales and crime rates. We find that as our sales increase, our crime rates increase. As the sales go down, the crime rates go down. That's interesting. So would we say that ice cream causes crime? Do you eat ice cream and want to go commit some crimes? Probably not. Do you think that committing crimes makes you want to eat ice cream? So anybody who sped on their way here is technically a crime. Does that make you want to eat ice cream? No, it's too cold. Is there something else that could be driving ice cream sales and crime rates? Yeah. Yeah. Temperature. We're just looking at ice cream and crime and not looking at anything else. We're missing a big part of the story, the temperature. So as the temperature increases, ice cream sales increase. So we've got ice cream parlors that are not open in the winter, at least in St. Louis we did. I'm assuming here too. If you go to stores, they have more ice cream available in the summertime because people are cold. They don't want to eat a cold thing mostly. Also, your crime rates go up in the summer. So I don't know about you, but if I were to break into somebody's house, I would not want to do it in the middle of the winter. It is too cold and you're going to slip and fall trying to get in their window. And that's just not worth it. I'm not breaking into people's houses, but you get the idea. Or if like at the state fair, I'm guessing, there's people who are pickpockets. They come and steal your stuff because everyone's out. Everyone's in a big group in the summertime and there's more opportunity for the crime. Or when it's really, really hot, people get really, really cranky and tend to have a shorter temperature and are more likely to swing on one another. I know when I'm hot, I get crabby. I don't punch people, but I yell at them in my car a lot. So these are all things that could drive up the crime rates and drive up the ice cream sales at the same time. So anytime you have a study, you're like, these two things are related. Could there be another reason rather than what's in the study? We'll talk about correlations more as we go, but if you are bored, you can search interesting correlations and find things that are related that you wouldn't expect to be. So like, I forget, there's one with Nicolas Cage movies. Like the more movies he has, the more something happens. I'll have to look that up. But there's weird relationships which probably have some other variable going on. We just don't know. Yeah. Really?
You just dropped.
Oh man, don't tell me that. Okay, so we have a relationship between wars and Wizard of Oz. There's probably something else going on that's, driving both of these things, but it's interesting. Yeah. We have lots of weird relationships. That's really scary. And now I'm going to stress about that thing. No, that's a good example for that. Okay, I have one piece left. I said PowerPoint, whoops, open chapter 1, slides 31 and 32. I don't just read off the slides because that's boring for you and for me, but there are some good examples in here and I will pull those off of here. I try to print them off for my in-person classes, but sometimes that doesn't happen. Can I zoom in? 31. Okay. With our observational versus experimental data, there are times where it's not appropriate to have an experiment. So our example here, cell phones and brain tumors. People are saying they think there's a relationship between cell phone use, like talking on it, and having more brain tumors. So we could read all of that. Is it ethical to take a group of people and say, okay, you guys, or you peeps, are all going to use your cell phones a lot, and you are not going to use them, and then in 10 years, we see if they have group 1 has a brain tumor versus group 2. Is that ethical? I really hope we're all thinking, no, that's not ethical. If we think something is causing harm in this way, we can't just say group 1, you're going to do the thing, group 2, you're not, and then we're going to compare. We don't do that. I hope we don't do that. So in this case, an experiment is not something we're going to do because we could kill people over that. But an observational study would be appropriate. So we look at people, maybe we'd look at people during year 1 and year 7 and compare them. Or maybe we compare 2 groups of people, though it's usually nicer to compare somebody to themselves. We compare that way. So we can observe, we can look back, but we can't say, you group, we think this is harmful. Please do this. You don't, so we don't. It's the reason why the cigarette cancer studies took so long, because we couldn't say, okay, you all are going to smoke. We're going to see if you have cancer. You all, we don't think you're going to get cancer if you don't smoke. You're going to do that. You can't do that to people. So observational. What we can do is take a animal and perform an experiment on them. I know there's ethics around this too. I get that. We're not arguing that, but that's more ethical than doing the trial on humans. So anymore, we could take a group of cells that don't have a brain and test it on them as well. But that's something we could do, is find rat studies and see, okay, you will be subjected to the cell phone signals, you will not. Let's come back in a while and see if there's a difference between the groups. Let's please not argue ethics in here. Everyone has a different thing. As long as we're polite about it, we should be okay. I really want to not cause fights in class over things like this. I know we have differences, and that's okay. There's more things you can read on this if you really want to dive into it. Yeah. Okay. I'm gonna stop sharing this. Turn my video off, maybe. Maybe. Mm, mm.